All right, so today we are going to graph polynomial equations using x-intercepts and n behavior. So what exactly is a polynomial equation? So a polynomial equation can be any like linear or quadratic or cubic or quartic, any of those connected by addition and subtraction. So for instance, you might have something like y equals mx plus b. Another one might be y equals ax squared plus bx plus c. That's your quadratic. You might have an x to the third in that. You might have an x to the fourth in that. Right. All of those are examples of polynomial equations. And you might only just have y equals ax squared, or you might just have y equals ax to the fourth. So any of those are polynomials. Well, we're going to be looking at their x-intercepts and their n behavior. So let's talk about n behavior. What is that? Well, we're trying to figure out what happens at the very right of the graph. So what happens when x becomes really large in that positive direction. And we're also looking at the far left on your graph, or the negative direction when x becomes really large in the negative direction. So when you say that x becomes really large in the positive direction, we're looking at it as x approaches infinity. All right, so that's looking there at the right. What happens when x becomes really large in the negative direction? We might represent that as x approaches negative infinity. So we're going to look to the far left. So let's look at some n behavior of polynomial functions. And those are determined by its degree. So that's the highest power of x. And by its leading coefficient, and that's always in front of the highest power of x. So if you look at our first example there, we just have a nice quadratic there. We're looking at an even degree, and we're looking at an example of a leading coefficient there as being positive. So our example here happens to be a quadratic, so it's y equals x squared. So its leading coefficient there is a 1, and 1 there is positive. And then its highest power of x in there is x squared. And 2, 4, 6, 8 are all even numbers, and that 2 there is an even number. So we're saying it has a degree that's even. So whenever you have a degree that's even and the leading coefficient is positive, look what's going to happen on the ends. The ends are going to go as x approaches negative infinity. Your y value there is going to be positive. And then as x approaches negative infinity, either there on the right-hand side, your y value is also going to be positive. So both of those are positive and going up. So I often say this is up and up on the ends. So let's go look at its relative over here. The same degree there. The degree there is even on the third one. So because it's even there on the third one there, its leading coefficient there is negative this time instead of being positive. So leading coefficient there is a negative 1. Its highest power of x in there is x to the second. And that's even, so it has a degree that's even. The leading coefficient there is negative. So what's going to happen at the ends? At the ends there, notice it's going down and down. Both are going down. So whenever you have some kind of a polynomial where highest degree and have highest power in there is an even power there, so the degree is even, and the leading coefficient of that term there is negative, you are going to have at the ends, end behavior is going to be down and down. So let's look at the two odd ones now, the two odd degrees. So those two odd degrees there, the second one there is leading coefficient is positive. What's happening at the ends of that one? Well, it's going down as x approaches negative infinity. What happens as x gets really large or approaches positive infinity? Well, your y value there is just positive. It's going up. So they're in opposite directions. And I like to say that's down and up for end behavior. All right, now look at the other one that's odd over there. It's going to be a negative leading coefficient there. So our polynomial this time is y equals negative x to the third. So our leading coefficient there is -1. Our highest power of x in there is x to the third, and the 3 power there is odd number. So we are going to say that is up and down. Again, if they're odd degrees, they're going to be in opposite directions. So let's sum this up in a table. So the end behavior of polynomials, when you have a positive leading coefficient there, and it's an even degree, it's going to be up and up there at the ends. So that's what it's showing there, up and up. When you have an even degree there and it's a negative leading coefficient, the end behavior is going to go down and down. When you have an odd degree and you have a positive leading coefficient, it's going to go down and then up at the ends. And then if you have an odd degree and you have a negative leading coefficient, it's going to go up and down at the ends. So just knowing that behavior of polynomials, if you're given this polynomial, could you match this up with some possible graphs here? So looking at this polynomial here, you've got x to the fourth minus x to the third minus 6x squared. What's the highest power of x in there? That's its degree. So highest power of x in there is the fourth, so that it has a degree of 4. Is 4 even or odd? The number 4 is an even. What's the number that's in front of that term of x to the fourth? It's a 1, and 1 there is positive. So we have an even and a positive. So have that quadratic in your mind. If it's even, what happens at the ends? It goes up and up. So they go in the same direction there. Letter A there, could that be a possibility? No, we just said it had to go up and up, and that one's going down and down. So this one here, down and down. We know that that one there would be an even one, but it would be negative, not positive. So it's not an option. Look at letter B there. What's going on at the end behavior? It's going up and up. So up and up, that's exactly what we want. It would be even and positive. What about letter C? What happens at the ends? At the ends there we have a down and we have an up. Those are opposite directions there, so we always know opposite directions there are odd. So when we have an even. What about letter D there? What's going on at the ends? It's going up and then down. So that would have to be an odd degree, and we have an even degree. What about letter E? What's happening at the ends? It's going up and then down. Up and down, that's odd degree, and we have an even degree. What about letter F? What's happening at the ends? It's going up and up. Up and up, that's good. It's even and going up and up. So that means that's even and it would be a positive. So both B and F in this case would work. All right, what about this example here? What's the degree of this polynomial? So the degree here is the highest power of x. What's the highest power of x in this one? It would be 5. Is 5 even or odd? 5 is an odd number. What about the leading coefficient of x to the 5th? The leading coefficient there of x to the 5th there is negative. So if it's odd, remember they go in opposite directions at the ends. So we know they go in opposite directions there. And then we have to think, does it start down and go up, or does it start up and then go down? I always have in my brain all the time the picture of y equals x to the 3rd. And y equals x to the 3rd looks like this. It starts down and goes up. So I always know that's the positive one. So for the negative one, this has to start down, up and then go down. So letter A there, would that be it? No, that's down and down. That would be an even function. What about letter B? No, that's in the same direction there. That's up and up. What about letter C? Well, letter C would be an odd degree, but would it be a negative? No, because that one starts down and then goes up. So down and up at the ends there is not a negative. So that would be a positive one, a positive odd. So this is odd. Letter D there, that one starts up and then goes down. Is that one going to work? Yes, letter D works. What about letter E? That starts up, goes up, and then down at the ends. So yes, letter E. What about letter F? No, both of those go in the same direction. They're both going up and up. So that's another even one. So both D and E are going to be negative and go up and then down. I'm just going to write this over here by this other one. I'm going to say this is odd and positive. So I always have that one in my mind. And then I have y equals x squared in my mind. Because if I have those two examples in my head, then I know that, you know, if it's y equals negative x to the 3rd, it's going to be up and then down. And then if it's even a negative, then I know it's going to be down and down, because it's just the opposite directions of what it's, the positive ones I have there. Zeros. Basically, what are zeros? They are our x-intercepts. Where do they hit the x-axis? All right, we'll talk a little bit more about that, but some things you need to know that you cannot have more zeros than the highest power of x in a polynomial function. So if I look at this one here, I look at the x-intercepts or the zeros there, I can see where they hit that x-axis there. So there are 4 zeros minimally. So we cannot say that this is negative x squared plus 4x minus 3, because minimally there, I know I see the zeros there. I know minimally there, I have to have an x to the 4th. Okay, because you cannot have more zeros than the highest power of x in the polynomial. And the highest power of x there is 4. So you can't have more zeros than the highest power. So down there, the highest power in our example down here is x to the 2nd. that would only have 2 zeros. Most likely would only have 2 zeros. It doesn't have to have 2 zeros for a quadratic, but most likely would have 2 zeros. That one has 4 zeros. So minimally there, I know that I would have an x to the fourth for that polynomial. And because it's down and down, the end behavior there, I also know it would be possibly a negative x to the fourth. So it could be a negative x to the fourth there. So let's look at something called multiplicity. There are different shapes of the graph based upon multiplicity. So if m is odd, so if you've got like x to the third there, so let me write out an example here. So if I have like x minus 2 there to the third power, my multiplicity there is 3 there because there's 2. My 0 there is at 2, and I'd have 3 zeros there at that spot. It has a multiplicity there of 3. So you don't like literally put 3 dots on the graph there at 2. You can only put 1 there, but it's a multiplicity of 3. Because it's x minus 2 times x minus 2 times x minus 2, so you would have 2, 2, 2. But you only see one graphing-wise. And so how we do that shape-wise is it kind of does that cubic that goes through that spot there. So the shape of my graph does that kind of a curve through that spot there. It's not very curvy. Something like that. So over there at 2. And so that's what happens when m there is odd. So what happens if your multiplicity there is even? So in other words, there you have a quadratic and we call it turns at that spot, or you could think of it as bouncing at that spot right here. So for instance here, if I had something like x minus 1 squared, and I were to graph that out, it would look something like that. And so what we say for that one there, it would have a multiplicity there of 2. And what would happen graphing-wise, it would bounce at that spot. You'd start down, go through the point, and then bounce back up. So it goes back in the same direction as it started at that spot when the multiplicity there is even. So let's come down here and let's kind of look at an example down here. So our example there, we've got a nice polynomial down here. So let's look at all the zeros on there. All right. So you can see that the one there on the far right over here, this 0 over here, that's just going straight through it. When it's going straight through it, it just exists there at 1. Some people will say it has a multiplicity of 1. And so that value over there is a 2. So if you want to state it, you could say it has a multiplicity of 1. I just don't usually state if it's more than, if it's less, if it's 1 or if it's 1, I don't usually state it has a multiplicity. But you can. And then look in there at, we've got the value there at -1 right here. So at -1, we end up there. It's doing that kind of a shape through that. Can you see the shape of it? It's doing that kind of a curve through that. So because it's doing that kind of a curve through that, we know that it has an odd multiplicity. And then over here at this one spot right over here, we know that that there has an even multiplicity because it's bouncing at that spot. It's starting going up and then it comes back in the same direction. So it has an even multiplicity. -4. So that's all the information that we can gather from that just by looking at that. Some other things that we could kind of guess at what this would be then. We could say it's y equals, and I'm going to plug them in. I'm going to show you what the equation here would be. We'd have x plus, when you're writing this out, it's always x minus your zeros. So it goes x minus a -4. And since it's bouncing there, we're going to go with a squared there. We're thinking it's probably squared. And then x minus -1 there. And it has an odd multiplicity, so we're going to do 3. You can't do 1. You got to do something greater than 1. And then our other one here is just a plain x minus 2. So really this becomes y equals x plus 4 squared times x plus 3 plus 1 to the third, and then x minus 2. So we'd say x equals -4 and has a multiplicity of 2. And we'd say x equals -1. It has a multiplicity of 3. And then x equals 2. Oops, it's a 1. I forgot they were going by 2's there. You probably caught that. And if you want to say it has a multiplicity of 1, you can do that. Multiplicity of 1. So we are going to sketch the graph of this polynomial function here, and then we're going to show the x-intercepts, all the intercepts, and has the correct end behavior, as well as it looks like we're supposed to do the y-intercept as well. So let's go ahead and let's graph this one out. So let's find our zeros. So how do we get 0 there? It just, whenever you have just a plain polynomial up there, there's nothing being added or subtracted to it, that's going to be equal to 0. So the zeros there would be x equals 0. How do you get 0 there? It would be, if you can't see it, you just take x minus 2 and set it equals 0 and solve for x. Well, obviously it's 2. And then how do you get 0 there? Again, you could just set it equals 0 and solve for x. And then our other one here, x plus 1 equals 0, x equals a -1. So those are our zeros there. Now let's state our multiplicity. So it has a multiplicity there at 0 there. It's to the 4th power there, so it has a multiplicity of 4. The second one there, x equals 2 there, it has a multiplicity of 3 because of the power of 3. And then at x equals -1, it has a multiplicity of 2. All right, so what we're going to do here, oops, we better do the y-intercept while we're at it. So how you figure out the y-intercept? So those are the x-intercepts. We're also supposed to find the y-intercept. So you want to go ahead and let x equals 0 and just plug it in there. So let's do that. So if we do that, we end up getting y equals 0 to the 4th times 0 minus 2 to the 3rd times 0 plus 1 to the 2nd. So then that just ends up giving us 0. So because x there was equal to 0, now y is equal to 0, our y-intercept there is just simply 0, 0. So let's plot these. Oh, and before we do that, let's also do end behavior, because that will help us too. So our end behavior, if you kind of think through this, we've got on the outside here, we have an x to the 4th. And here, if you were to multiply x minus 2 times x minus 2 times x minus 2 there, you're going to get an x to the 3rd something. So the highest power of x there is going to be x to the 3rd. And then the next one here, x plus 1, to the second, that means x plus 1 times x plus 1. If you were to fold that out, the highest power of x in there would be x to the second. So I can just go ahead and I've got x to the 4 times x to the third times x to the second. Remember, you add those powers, and we get x to the ninth. So it is going, that's 9 there, is an odd degree. And it is a degree of 9, and it's odd, and we also know it's positive. We know it's positive because the leading term there would then be a 1 in each case there. It's not like there's a negative x to the fourth on the outside to make it negative. So degree is 9 and it's positive, so we got an odd and positive. So what's the end behavior going to look like? It's going to be down and up. So let's go ahead and graph that. Go ahead and graph out your zeros. All right, the y-intercept we know as well. Well, the y-intercept ends up being one of our zeros, so we don't have to worry about graphing that one up. We know at the end here, this has to go down, and we know at this end over here that this has to go up. All right, so the first zero we have to go through is a -1. It has a multiplicity of 2, so it's going to bounce there. We don't know exactly where that's going to come down to, but it has to come down and then go back up. And then at the next value there is at 0, and 0 has a multiplicity of 4. And whenever it's even multiplicity, it's going to bounce. So it's going to bounce at that one as well. And then our last one there is a 2, and at 2 it has multiplicity of 3. And so remember how it does that. It does kind of that cubic kind of a graph through that. So it does kind of this kind of a shape through something that's higher than 1 there. That's an odd. So there we have our graph. And now we don't know where these little valleys in here are. We don't know exactly where those are. We're just trying to get the basic shape of it. All right. Let's try another one here. It's nice when they're factored like this for us. So looking at this one here, notice they don't have any powers up here, so these are 1s. So our zeros there. How do you get 0 in that first one? Well, you just set it equals 0 and just 0. How do you get 0 in the next one there? It'd be x minus 3 equals 0, so you end up getting x equals 3. The next one there, x plus 1, set it equals 0. Solve for x. So at x equals 0 there, we're going to have a multiplicity of 1, if you want to write that. At x equals 3, a multiplicity of 1. And at x equals -1, a multiplicity there of 1. So now let's identify the y-intercept. Y-intercept, remember you got to substitute 0 in for x. And so we end up there with 0. So again, we get that 0, 0 as we did last time, because the 0 there was a 0, and the x-intercept ends up, or the y-intercept and the x-intercept end up being the same there in that case. End behavior. End behavior of the graph here, we have an x here, and then times x times x. And we get x to the third. So that has a degree of 3. And it's odd because 3 is an odd number. And then it's positive. We don't have a negative x in either one of these cases, so it's going to be positive. And so if you have that y equals x to the third in your head there, you know it's going to be down and then up. So let's graph that. Plot your zeros. End behavior is down and up. So they all just have multiplicity of 1, so you can just go through them. We don't know where they turn when they go up, but they're going to have to turn when they go up. So something like that. We don't exactly know where they come down or go up to in those curves, but that gives you an idea. I'm going to redo the end of that one. There. It kind of looked like it was doing a cubic through that, and I didn't want it to do that. All right, and then our last one there is I want you to try this one out, so you could pause the video and try and see if you can do that, and then see what I do. All right, so the zeros. Hopefully you found these out here to be x equals 0, because how do you get 0 on the outside when x is 0? How do you get 0 here? You can set it equal 0 and solve for x. So that first one there, x equals 0, because the power up there is 2, it has a multiplicity of 2. That's next one there, x minus 3 has a multiplicity of 1. Find your y-intercept. So again, you just substitute 0 in there for x. And we end up getting 0. So when you substitute 0 in for x and you get 0, then our ordered pair there is 0, 0. End behavior is our last one. So on the outside, right out here in the front, it's a x squared. And then inside here, we just have a plain x. So if you multiply together, you get x to the third. So my degree here is 3 and odd. So I'm saying odd because 3 is an odd number. What's in front of all these? They're all positive numbers in front of the x squared and in front of the x there, so you're going to have a positive. So that means my end behavior is going to be down and up. So let's graph that. Zeros. 0 and 3. So at 0 there, we have a multiplicity of 2, so it's going to bounce. And then they're at 3 there, it has a multiplicity of 1, so it's just going to go straight through it. So then there's your assignment.